हेलो स्टूडेंट्स, वेलकम टू माय चैनल फिजिक्स ट्रिक्स। सो लास्ट वीडियो में हमने देखा था केप्लर्स लॉज एंड न्यूटन्स यूनिवर्सल लॉ ऑफ ग्रेविटेशन, डिडक्शन ऑफ न्यूटन्स यूनिवर्सल लॉ बाय यूजिंग केप्लर्स लॉ, राइट। ये सब हमने देखा था। तो आज हम देखेंगे कि व्हाट आर द न्यूमेरिकल्स व्हिच आर बेस्ड ऑन न्यूटन्स यूनिवर्सल लॉ ऑफ ग्रेविटेशन के बारे में। सो देयर आर 6 मॉडल्स इन न्यूटन्स यूनिवर्सल लॉ ऑफ ग्रेविटेशन। So number one, first model is, let us suppose we have all the masses which are placed on this axis, right? Now what is the force on this mass m which is placed at the origin, right? So that we have to find out. So we have, this one is the first model, you can say. Now second model is, and these masses are at infinity supposed to be, and you have to find the force of attraction on, net force of attraction on this m due to all other masses. तो वो कैसे आएगा वो मैं बताऊंगा जब ये 6 मॉडल्स होने के बाद। ओके, सो नेक्स्ट मॉडल जो है वो है, लेट अस सपोज वी हैव the masses which are placed on the triangle. Now this shape might be anything, that this shape might be square, this shape might be pentagon, this shape might be hexagon, right? So this is the second model which we have. Okay, now third model is, let us suppose we have the extended body. This is the extended body, and we want, this is the point mass, this is the extended body of mass m and length l, and we want the force of attraction between this extended body and a point mass. So this is the third model which we have, right? So fourth model is, let us suppose we have, this is the mass m1 and this is the mass m2. Now this mass m1 and m2 will be attracted towards each other, right? And we take this mass m1 as fixed mass. Okay, now this is these two masses will be attracted towards each other, and let us suppose this m2 is at infinity. Now this m2 will come closer to this m1, isn't it? Now when this m2 is at a distance of r supposed to be, what is the velocity of m2 that we have to find? So this is the fourth model which we have. Okay, this is the fourth model. Now fifth model is, let us suppose the force of attraction, now the force of attraction is directly proportional to the r to the power n, right? Force of attraction, the same force of attraction is now directly proportional to the r to the power n. Now what is the time period, what is the time period directly proportional to r to the power of what? If f is directly proportional to r to the power n, then time period is directly proportional to r to the power of what? This is the fifth model which we have. Okay, and sixth model is like, we have, let us suppose we have the capital M mass, right? Capital M mass, and we split this mass into two parts, right? So that parts are small m and capital M minus small m. If we split capital M into small m, then m minus small m is the second part, that is this one, m minus small m. Now what is the value of small m? What is the value of small m value of small m so that force of attraction between these two masses, that is small m and capital M minus small m, is maximum. These are the 6 models which you have. Now in this, series might be anything, right? So in this you will get series, geometrical series, you will get arithmetic series, you will get arithmetic progression, you will get geometric progression, you will get 1 square plus 2 square plus 3 square. So I will do here one by one. So first model I will take, and in this I will do the problem on this model, one problem. Likewise, this is the second model, on this one problem, and I will show what are the possible questions which are asked in IIT, JEE or NEET. Likewise, third, fourth, fifth, and this is the 6th model, right? So these are the 6 models which are very important in terms of NEET as well as IIT, JEE. Okay, now we'll do. अब देखिए हम देखते हैं अब फर्स्ट मॉडल, राइट? सो इसमें फर्स्ट मॉडल जो था हमारा वो था कि एक एक्सिस है और इसमें सपोज टू बी फर्स्टली एट ओरिजिन स्मॉल एम मास रखा है. ओके, सो व्हिच इज एट 0 डिस्टेंस. लाइकवाइज एट 1 मीटर लेट अस सपोज वी हैव another m mass. At 2 meter we have, let us suppose, 8 m mass. At 3 meters we have, let us suppose, 27 m mass, right? So likewise it continues, right? Okay, now see, force of attraction due to this m on this m is towards this line only. As we know that gravitational force is a central force, right? So force of attraction due to m on small m is towards this line. Due to 8m on m is on this line only. So that also on this line, 8m on small m suppose. So likewise all the forces will be in the same direction. As all the forces in the same direction, we can say that we can add the net force. We can say first force, that is Fmm, plus the second force, that is F on m due to 8m, plus on m due to 27m, and plus and so on, isn't it? Right? Okay, so all the forces are in the same direction, so we can directly add. So F net we can directly say Fmm is gm square by 1 square, plus likewise gm 8m is 8 gm square by 2 square, plus likewise yes g m square, that is 27 gm square by 3 square, and plus and so on, which is equal to, now gm square by gm square is common, right? So gm square is common, in bracket 1 plus 8 is nothing but 2 cube divided by 2 square, plus 27 is nothing but 3 cube divided by 3 square, plus likewise so on and so forth, right? So here we'll get 4 cube divided by 4 square, 5 cube divided by 5 square, and so on. So which is equal to gm square in bracket say 1 plus this 2 square, this 2 cube, this 3 square, this 3 cube. So 2 plus 3 plus 4 and so on and so forth. So which is equal to gm square in bracket. So what is the addition of n terms? Sum of n natural numbers, right? And that is n of n plus 1 divided by 2. It is that simple, isn't it? Now if they gave likewise 10 masses supposed to be till 10, that is 10 meter, and 10 cube. Right, so just put the value 10 over here, n is equal to 10, and you will get the answer. And what is that answer? 10 plus 1 divided by 2, that is 55 gm square is the answer. Right, so for 10 it is 55 gm square, for 20 it is 20 into 21 divided by 2, that is 10 into 21, 210 gm square is the answer. So now the second model, right? Okay. Now see, we have the three masses which are placed at the vertices of the equilateral triangle, right? Okay. Now what is the force of attraction, net force of attraction on this small m, right? Okay. See, we have the force of attraction between this small m and small m, this towards the small m, and likewise the force of attraction between these two is towards this small m. As this is the equilateral triangle, the side must be equal. And what is the angle over here? It is 60 degree, 60 degree and 60 degree, right? Okay. Now force, this force F and this force F is equal in magnitude but different in direction. So force magnitude we can write F is equal to two masses which are placed at a distance A. By using Newton's law we can write gm square divided by A square. Now magnitude is same. So we have two vectors which are equal in magnitude. Let's suppose F and F at 60 degree. Right. Now this question might be asked, what is the net force on this small m? What is the net force on this small m? Answer is equal. Right. Answer is same. Okay. Now what is the resultant of this? The resultant is this is the resultant, right? So this is the R and this is F, and by using parallelogram law we can say this resultant R is equal to root of F square plus 2F square, cosine of angle between these two vectors is 60. So which is equal to root of F square plus F square plus F square. Why? Because 2 into cos 60. Cos 60 is 1 by 2. So 2 into 2 cancel out and we'll get F square, which is equal to, right, root 3 into F. So net force on that small m is equal to, we can write root 3 into F. F value is gm square by A square. Okay. So this is the second model. Now in this, tell me, if instead of this small m, we have 2m. Right? Instead of this small m, we have 2m. And they are asked, what is the net force on this? 2m. So what is the difference between them? What is the difference now? Due to this small m on 2m is g 2m into m divided by A square. Likewise due to this force magnitude is same, but over here only the value 2 will come. So 2 gm square by A square. So what is the answer here? 2 root 3 gm square by A square. Likewise, they increase this mass and ask the net force on small m. You can do that problem also. If they asked, let us suppose we have 4 masses, right? M, which are placed at the vertices of square, and they are asked what is the net force on this small m due to this all other small m. So force due to this on this is F. Force due to this mass on this mass is F, and this one more force is there, and that force is along the diagonal, isn't it? And this is F dash supposed to be, right? So this one F which are at an angle 90, and this one is F dash, right? So this two resultant will come in the direction of F dash, and you will calculate the value, right? So this is the second model. Instead of supposed to be square, we have hexagon, we have pentagon, and all. Now we have third model, right? Okay. So third model. In this we have, let us suppose this is the extended object and this is the point mass, right? Small m supposed to be, and this is the extended object of mass m and length L, and this small m is placed at a distance of a from this extreme end. Okay, now we have to find out the gravitational force of attraction between this extended object and a point mass. For that, see, due to this small element, there is a force of attraction, and that is g dm into m divided by a square. Likewise, due to here, the force is different. Due to this mass, force is different, and that is not a linear progression. That is not a linear answer, you can say, right? So, for that, we have to use integration. And what is that? We have to go from this small m at a distance of x, and we have to consider a very small element dm, right? Now this dm is equal to, now this is the very small element, and that is equal to, and this extended object has a constant density, constant linear density, so which is equal to, dm is equal to mass by length into small element is dx, right? Okay. Now this dm, how this will be true? Because this has uniform density. And what is density? Mass by length. Uniform linear density, uniform areal density, uniform volume density. Mass by length is nothing but linear density. Mass by area is nothing but areal density. Mass by volume is nothing but volume density, isn't it? So likewise. Okay. Now see, due to this small dm element on this m, what is the force of attraction? Distance between this dm and this m is x. So we can write the small force df as g, yes, dm into m divided by x square, isn't it? Now this df is equal to g dm m by x square. Now what is dm? M by l into dx. So which is equal to gm by x square into m by l into dx, right? So which is equal to, now see, g capital M small m divided by l dx by x square. Now integrate this term from, see, from a plus l, that is this extreme end, till a, this is a plus l till a, isn't it? And a is this extreme end. So from this end till this end we have to integrate. So integrate it. So integration of df is f, that is total force, that is equal to g capital M small m divided by l integral dx by x square. And we have to integrate it from, tell me, from a plus capital L to a, right? To a, and that is equal to g capital M small m divided by L. What is the integration of 1 by x square? It is minus 1 by x, right? So x to the power minus 2 upward, x to the power minus 2 plus 1 divided by minus 2 plus 1, that is minus 1 by x. So directly I am writing here, it is minus 1 by x from a plus L to a. And in integration, we know that if minus sign is there, put lower limit first and then the upper limit. It will be like G capital M small m divided by L. What is the answer then? 1 by A plus L minus 1 by A. So this is the answer, and this is our third model. Now we'll start with fifth model. So in this model, we have, let us suppose this is the M1 mass and this is M2 mass, which is at infinity, right? And we want what is the velocity of this M2 mass when it comes from infinity to given point, and that given point, let us suppose at a distance of r, and we are considering this mass is fixed mass. Okay, so now see, in this we have to apply the integration, right? Calculus, you can say. Why? Because whenever this mass is coming closer and closer, the acceleration of that mass is the acceleration is constant, but the velocity is increasing, velocity is changing. So for that, we have to take at x distance a dx element, let us suppose, right? Now at this point, what is the force of attraction between M1 and M2? Right, so that force of attraction F, we can write it as, see here, G M1 M2 by x square, right? Okay, now we want to find out the velocity at this point, right? So V, what is that V? Okay, so what is F? F is nothing but force at this point. And what is that? G M1 M2 by x square. Or else this F can be written as mass of this body into acceleration at this point. So let us consider that M2 into A, which is equal to G M1 M2 by x square. Now this is always a force of attraction, so this must be with negative sign, right? So this M2 get cancelled, and acceleration we can write minus G M1 by x square. Right. Now acceleration, what is acceleration? Acceleration is nothing but, see here, acceleration is a dv by dt, and which is equal to, we can write dv by dx into dx by dt, isn't it? Now what is this dx by dt? Rate of change of position is nothing but velocity, so v dv by dx. Now use this equation over here and we'll get, see here, v dv by dx is equal to minus g m1 by x square. Now this v depends on this dv and this x depends on this dx, so separate the variable, it will be minus g m1 by x square into dx. Now integrate it. So it will be v squared by 2, and what is the limit? Limit is, initially velocity is 0, that is at infinity velocity is 0, at r we have to find out the velocity. See, at infinity, this is the infinity, velocity is 0, and at this r distance we have to find velocity, right? These are the limits. Okay, now this is from 0 to v, which is equal to minus, and what is the 1 by x square integration? It is minus 1 by x, so minus minus plus, so directly I am writing here plus in bracket 1 by x from infinity to r, and this g m1 is constant, right? So final expression will get as, see here, this is v square by 2, so put upper limit, so v square divided by 2 is equal to upper limit 1 by r, lower limit infinity, so it is directly g m1 by r, so v will get as 2 g m1 by r root. So this is the fifth model, right? Fifth model. And it is very simple. This is nothing but what? This is the escape velocity from this point to infinity point. So V is the escape velocity of this mass due to this mass m1. Now we have the fifth model. So this one is fifth model, and it is, if force is directly proportional to r to the power n, then time period is directly proportional to r to the power what, right? So ये हमको देखना है. तो इसमें देखो ये बहुत सिंपल है. Force is directly proportional to r to the power n. Now Newton's force is for the orbit for the any two masses, isn't it? So if any mass is moving in a circular orbit, that mass experiences a force. That force is called as the centripetal force. So this force can be written as centripetal force. So that is equal to mv square by r, and which is equal to some constant k into r to the power n. Okay. Now V is equal to, we know that r into omega. If you put over here, you will get m omega square r is equal to some constant k into r to the power n. Now this omega square is equal to m and this one in this side. So k by m r to the power n minus 1, because r this side will be r minus n minus 1. So omega is equal to root of k by m into r to the power n minus 1 by 2. Just taking the square root on both sides. Now what is omega? It is 2 pi by capital T, which is equal to root of k by m into r to the power n minus 1 by 2. Okay, now see this T, that side, it will be T is equal to T this side, R this side, so it will be 2 pi root of m by k into r to the power minus of n minus 1 by 2. Right, so this is constant, so we can write T is directly proportional to r to the power minus n minus 1 by 2. Right. So if they give r to the power minus n, so it will be minus n minus 1 divided by 2, and answer for that, if f is directly proportional to r to the power minus n, then time period is directly proportional to r to the power n plus 1 by 2. Why? Because minus n minus 1 minus common minus minus plus. So this is the answer. So they might give r to the power minus 5 by 2. So just put over here minus 5 by 2. It will be 5 by 2 plus 1. And what is the answer? 7 by 4. So r to the power 7 by 4. Right. So likewise you will get the. Now we'll see the sixth model. And it is, let us suppose we have the capital M mass. And we have to split this capital M mass into two segments. Let us suppose M and capital M minus small m. Now what is the value of this small m, so that force of attraction between these two masses are maximum, right? Force of attraction between these two masses are maximum, right? So this is the question, right? So now see, it's very simple. Now variable is small m. Now let us consider the capital M is split into two parts, and that is M, and this one is capital M minus small m, and these two are placed at a certain distance, supposed to be x. Now what is the force of attraction between these two masses? The force of attraction is same. That is the Newton's gravitational law. By using Newton's gravitational law, we can say F is equal to G small m capital M minus small m by x squared. Now the variable is small m and we have to maximize the function. So for maxima, let us suppose we have the function y is equal to f of x. Right. So for maxima, we have to differentiate dy by this function, that is f of x, with respect to x and equate it to 0. And if d2y by dx squared is lesser than 0, then this function for this values is maximum. And if d2y by dx square, that is d square y by dx square, is greater than 0, then for this values this function is minimum. Right, so minimum. So this two you have to remember. अगर आप में से किसी को इसमें कुछ प्रॉब्लम है तो कमेंट में जरूर लिखिएगा, so that मैं उसके ऊपर एक वीडियो बना पाऊँ. ओके, सो ये आपको याद रखना होगा कि dy by dx अगर 0 है और d2y by dx स्क्वायर लेस देन 0 है तो मैक्सिमम होगा, और d2y by dx स्क्वायर अगर ग्रेटर देन 0 है तो मिनिमम होगा. तो अब हमको इस फंक्शन को डिफरेंशिएट करना होगा. तो डिफरेंशिएट करते हैं, चलो देखिए. df by dm. Now here m, why? Because m is variable. Okay, is equal to g by x square is constant, d by dm in bracket m capital M minus small m, right, which is equal to, now this is u and this is v, right. If you differentiate this, it will be g by x square in bracket small m u into dv by dx, it is 0 minus 1 plus m minus capital M minus small m into d by dm of small m is 1, right. So which is equal to, we have to equate it to 0. So we'll get capital M minus 2m is equal to 0, and we'll get capital M is equal to 2m, and from this we'll get small m is equal to capital M by 2. Right, so this is the answer. So small m is equal to capital M by 2. This represents what? If this function, this is capital M by 2 and this is capital M by 2, the force of attraction between these two masses is the maximum. Why maximum? If you double differentiate this term, you will get minus value. How? See here, g by x squared, value over here is df by dm is equal to g by x squared in bracket capital M minus 2m. Now if you double differentiate it, it will become minus 2. Minus 2 into g by x squared. Minus 2 means what? Minus means what? See here, less than 0. Less than 0 means what? Maximum. That means for m is equal to m by 2, this function is maximum. So this is the our sixth model. So this is it for today. ये 6 मॉडल्स थे, और अब ये 6 मॉडल्स में आप अगर आपको कुछ भी डाउट हो तो कमेंट बॉक्स में ज़रूर लिखिएगा, एंड उसके रिलेटेड मैं जितने भी वीडियोस होंगे वो बनाता रहूँगा. सो दिस इज इट. थैंक यू फॉर वॉचिंग दिस वीडियो. इफ यू लाइक दिस वीडियो, सब्सक्राइब इट एंड प्रेस द बेल आइकन फॉर न्यू अपडेट्स.